Hey y'all, welcome to our new unit. In this lesson, we are going to be estimating solutions by inspection. So our new unit is systems of linear equations, and in this lesson, we will estimate solutions by inspection. So our I can statement is, I can find the number of solutions of a system of equations by inspecting the equations. Let's define a couple of things. A system of linear equations. This is formed by two or more linear equations that use the same variables. So we'll traditionally see a ton of x and y. So it's going to be sets of equations that both use x and y. And you could graph them on the same graph. And a solution to these is any ordered pair that makes all of the equations true. Okay, so if you have one point or one ordered pair that you can plug into both equations and get a true statement, then it's a solution to the whole system. Okay. Our essential question is, how are slopes and y-intercepts related to the number of solutions of a system of linear equations? So we're going to be looking at the slope and the y-intercept of each of our lines. Deanna drew the following pairs of lines. Each pair of lines represents a system of linear equations. How can you use the graphs to determine the number of solutions of each system? So as we look at the graphs, we see blue, red, and green. Blue lines, they intersect at one point. The red lines, they never intersect, they're parallel. And the green lines, it's two lines actually right on top of each other. So keep in mind that the solution is a point that makes both of the equations true. And when we're looking at that graphically, that it is going to be a point that falls on both lines. So we often call this the intersection point. So we can see that the blue line has one solution, the red lines have no solutions, and the green lines have every point on the line is on both lines. So that one would have infinitely many. Let's take a look. So we see that the slope of one of the lines is +1 and the slope of the other one is -1. So we can inspect their equations by noticing that they have different slopes. So because they have different slopes, this has one answer or one solution. And in this case, that solution is the point at 1, 5. For the red lines, these lines do not intersect, they are parallel. Because they never intersect, this one has no solution. You'll notice that the slope for both of these is the same. They both have a slope of 1. However, they have different y-intercepts. One is +3 and one is +1. So they have same slopes and different y-intercepts, and that's how we can look at the equations to know that there is no solution. The last one, we have the lines that are intersecting at every point. They are the same line, and so the system has infinitely many. When we look at their equations, what we notice is that the line has the same slope of -1 when graphed, and it goes through the same point on the y-axis of -2. So because they have the same slope and the same y-intercept, they represent the same line, and we say that there are infinitely many solutions. You try it. How many solutions does this system have? Y equals x plus 1, y equals 2x plus 2. The equations have same or different slopes. So the lines intersect at 0, 1, or infinitely many points. Fill in your blanks. In example 2, we are looking at Harrison and Pia. They are buying X number of comic books. Harrison also buys an action figure for $15, while Pia buys a different action figure for $12. Could they spend the same amount, Y, and buy the same number of comic books? So we set up a system for this. And the system that we set up is y equals 5x plus 15 and y equals 5x plus 12. The 5x, we can see from the picture that comic books are $5, so that's where we get the 5 on x, and it's x comic books. Then One of them spends $15 for sure, and the other one spends $12 for sure. So that is why we have plus 15 and plus 12. When we look at the equations, the slopes are the same, 5x and 5x. However, the y-intercepts are different, 15 and 12. Because of this, there is no solution. So Harrison and Pia cannot spend the same amount of money and buy the same number of comic books. Let's look at one more example. Corey and Winnie each bought X pounds of cheddar cheese and Y pounds of tomatoes. Corey spent $12 at the supermarket, and Winnie spent $24 at the farmer's market. Could they have bought the same amount by weight of cheddar cheese and tomatoes? So we see the supermarket price of 2 pounds per tomato and 6 pounds per cheese. Again, X is going to represent cheese and Y is going to represent tomatoes. So you see the first equation we have is $6 for cheese, or 6x, plus $2 for Y, the tomatoes, is equal to the $12 Corey spent at the supermarket. The other equation, 12x plus 4y equals 24, is because cheese costs $12 per pound and tomatoes cost $4 per pound at the farmer's market. First, what we want to do is write each equation in slope-intercept form. This will allow us to see the slope and the y-intercept. So you can see my equations over here, and we're going to look at this one step at a time. The first step to change from standard form to slope-intercept is to subtract over the x term. So I've subtracted 6x and I've subtracted 12x. The next step is to divide by the coefficient on y. So in the left side, I'm going to divide everything by 2, and on the right side, I'm going to divide everything by 4. I get y equals negative 3x plus 6 for both equations. That tells me that it's representing the same line, and so it has infinitely many solutions. So Winnie and Corey must have bought the same amount of cheese and tomatoes. One spent more at the farmer's market, but they still bought the same amount. Here are 2 examples for you to try. One requires you to change over to slope-intercept form. How many solutions does each system have? 1, none, or infinitely many? Summarizing what we have learned today, you can inspect the slopes and the y-intercepts of the equations in a linear system in order to determine the number of solutions. Again, it will be one solution if you look at the slopes and they are different. However, if you look at the slopes and they are the same, if the y-intercept is different, there will be no solution. If the y-intercept is also the same, then there will be infinitely many solutions. You can see, especially in this third one, that our equation can be written in a slightly different order, so make sure that you are identifying that slope and y-intercept correctly. Your next steps are to turn in your 6.1 notes, complete your build 6.1 and your 6.1 mastery check. Good luck.